Does that work? Oh, great. I have to say I'm extremely nervous for a number of reasons. One is to be on this side of things at the school I graduated from was a little strange, and to be talking with George Baird, whose essays when I was a youngster were transformative in my life, is a real honor. So welcome. Thank you for coming, and I apologize for the quality of the lecture in advance because it's a bit choppy and it won't be as focused as I think some of the following lectures will be. And it's more of a personal meditation in some ways of how I came to be at Bregman and Hammond and how I'm still there 20 years later. And so it is about the second life of tall buildings, but it begins actually a little earlier in Rome, which I'm just pandering to Waterloo because that's where it all begins. But the point of showing Rome is just to talk about a personal preoccupation I have with massive buildings, and kind of always have had. The first kind of thing that turned me onto architecture is my father took me to the Toronto Dominion Centre construction site in 1967, and it was, for some reason, that was transformative as well in my life. And I've always kind of fought this desire to make very large buildings, and during my career in co-op and so on, was always kind of resisting them and working for boutique firms. Because my very first job was at Mathers and Haldenby, a now defunct firm which gave the genesis to the dean of the school, the director of the school, and it was one of the worst jobs I've had in my entire life. And I never wanted to work for a large practice again. But 20 years ago, I found myself drawn to B&H through a series of sequences, and thought I'd be there for 3 months, and 20 years on, I'm still there. And Donald is right, I'm quite proud of the fact in some ways. And the reason for talking about Rome is that it was the first place where I kind of came to this weird understanding of the palimpsest of the modern city that dates back over 2,000 years. And which one?
You're okay?
I think I'm okay. Is that okay? Okay. And this is just the classic Domus Aurea, which I think is one of the great sort of the space itself is amazing and quite interesting, but to me the drawings of the thing are actually far more fundamental and interesting, and actually talk to the condition of the city as kind of a series of layers, and in this case layers of very, very large structures, beginning with the Domus Aurea, which was quite a bit larger than this whole thing, that 10 years after it's constructed is fully renovated and destroyed by Trajan, by a kind of marketplace that gets stuck on the top of it. And I've always liked this drawing because it in fact is almost incomprehensible, but it shows the kind of ability of architects to take a piece of structure, bury it fully underground, and then build the new program of construction on top of it by creating a brand new system of foundations that then the city gets instituted on up above that. So in my time in Rome, our focus was in this area here, and I fell in love with this particular structure. And part of the reason for it was, it's the Theater Marcellus. It was a perfect piece of Roman architecture, massive in its nature and its consistency of development. It was, a seminal piece of structure at the time it was built, but then as time moves on, it gets completely consumed by the medieval city and taken over and becomes a refuge of the poor. Fish markets get built into the base and around it, and it slowly sinks bit by bit into the layering of the city as it moves up. Mussolini at some point tries to clean it up and turn it back into the kind of structure it is, but by that time it's already being completely consumed by the Barbarinis on one hand and then various apartments on the other. And then across the way at the Portico of Octavius, it's now consumed by a church, and the old city is almost a full level below grade. But it just keeps on getting reinterpreted and redigested into the city. And in some ways, it simply can't go away. So here it is in its genesis. Here it is now. It's basically become a hill town. The structure is still fully intact underneath this, with the city growing on top of it. and basically the landscape sort of being reintegrated with that structure. And for me, that's actually what the city is, and what my kind of, I take this kind of joy in walking around in our city in Toronto and seeing these components that have been around for years. They keep getting reinterpreted, they keep getting pulled apart, they keep getting put back together. But at some point, really, the city becomes discernible as a kind of massive organic structure that's almost continuous, which takes me to B plus H. So B plus H has been around since the 50s. It was a firm that was, essentially built on the TD Center as a kind of success story. It was one of the very first Jewish firms to actually break through the stranglehold of the WASP elite in Toronto, so it has a kind of weird relationship to power structures. And it's been responsible for every one of these blue dots, all of which basically constitute a massive chunk of the city. And for the most part, has continued a relationship with all of these blue dots in either the form of restructuring these buildings or additions to these buildings or transforming these buildings. Many of these buildings are completely prosaic, and many of them are we're the execution architects, where we've worked with Mies van der Rohe or Daniel Libeskind, or like almost the pantheon of star architects in the world, and many of them are also buildings we designed from scratch. And so the kind of relationship to construction is very straightforward, as in we are builderly, we are master builders, will take on anything, and our egos are generally subsumed except for within the office itself. And as a consequence, we have also been involved with massive pieces of infrastructure, both in Toronto and around the world. And these are kind of the unsung pieces of what architects do that nobody knows anything about. So, for instance, all the infield buildings at Toronto's Pearson Airport was a kind of a $1.5 billion building program. B plus H did, and you'll never hear about it, you'll never see an image, and so on and so forth. But we designed a building that you can fit 3 747s in, which to me is incredibly cool. And I have a kind of real passion for the puzzle of making these things. And as Donald commented, this is my first building at B plus H, and you can't see it. There's this teeny building on top, but the structure itself consists of this entire piece. It's underground. It's effectively a 10-acre site. We took down half of the roundhouse and rebuilt it on top of the convention center below grade. And as part of that building program, I'm just going to point out that B&H is also involved in the rest of these projects around. But as part of that building program, we built this piece here, which is the truck loading dock. And I was amazed at the time that when we did this, there was a component of that which to build this massive cistern, which does nothing but for converting water, you'll see in a second, and it sat there empty for 10 years. We also built the John Street pumping station, not a particularly great looking building, but then if we fast forward 10 years, we got involved with the Deep Lake water cooling project. And this turns out to be one of those great pieces of infrastructure in the city that almost nobody knows about again. But it starts with taking a problem in Toronto of lousy drinking water, wanting to add capacity to the drinking water system, and at the same time, a group of engineers come along and say, look, there's a real thing we can do here to reduce refrigeration plant energy loads in the downtown core of the city by taking this drinking water and sucking some of the energy out of it. So the project itself consists of 3 4-kilometer lines that go out into the water. It hugs the base of the shoreline and goes fully out that 4 kilometers till it can reach water that doesn't stratify at the base of the Lake Ontario. It stays at a consistent 4 degrees Fahrenheit. So you bring this water in, it goes into comes into the Toronto island pumping station, filtration station, which itself is an old structure that's been there forever. It hadn't been used for some 25 years, but it's now being fully reinstated in the city with new machinery and so on to filter that water. That water comes into the John Street pumping station, which B&H produced, and again, this was the original structure that sat where Skydome was, and then this is the new facility. Within that space, we bring in the water at 39 degrees and take out basically what amounts to about 2 degrees off of that to generate almost 40,000 tons worth of cooling. And below this system, below grade, there's this massive, massive room that you will never see. No one's allowed to go in there because, of course, it's a strategic asset that has these. There's this guy here. You can see he would stand about this high. And all the drinking water for downtown Toronto comes through this system, and a piece of it gets knocked off to generate cooling. And that then it goes and sits in the cistern on the ramp for the Metro Toronto Convention Center, where it's combined with incoming coolant and then pushed out to the rest of the city, uptown to the core of the city and all the way up to Queen's Park, which you can see here. So this is the kind of continuous system. And it has quite a number of buildings on it, in particular the TD Centre, which we've just put on there, and the Royal Bank Centre, which I'm going to talk about for a second. So to me, what's a kind of extraordinary about that is it's a massive system that's leveraging a kind of component of the city, which is drinking water, to generate something that's sustainable, but it's not the kind of the way we think about sustainability, which is small and local. It's actually large and systemic. And it's and also the fact that, again, it's a thing that architects do and have to be part of, and coordinating consultants and so on, which generally is completely unsung and kind of disappears into the background of our profession. So I'm just going to quickly talk about the RBC Centre as the first building in a kind of transformation of the office building in the core. So the N-Wave system runs coolant into the RBC Centre, which is the largest LEED Gold certified building in Canada right now, and we'll talk about that in a moment. And it has all the kind of classic components. And by the way, this was part of this was developed with Dermot Sweeney, who's got a kind of sustainability practice for working on these projects. It combines several very sort of intense pieces of kind of sustainable components, including displacement ventilation, which uses sort of natural convection currents of equipment and people to drive the fresh air up towards the ceiling so it can be drawn off at the top, so it means the air is much cleaner instead of trying to push dirty air down. Light shelves, high quality glazing systems, perimeter heating, and so on. It harvests rainwater so that all the lower 10 floors are fully flushed by rainwater, and that's sequestered on these two rooftops, as well as using that water for irrigation systems. And then, of course, the chilling system from the N-Wave plant reduces the load significantly, energy use of this building significantly. So this is the kind of section that we developed for the building with sunshades that reduce the direct solar glare, automated roller blinds and light shelves that drive daylight further into the space, and indirect lighting on the ceiling and exposed concrete systems. Now, to me, what's interesting about this, it's LEED Gold and so on, but in some ways, it just shows how far we are from being a sustainable environment, and that it's floor-to-ceiling glass on all 4 elevations. So in some ways, it's kind of bogus. But nonetheless, this is how marketing goes, and there was no point in even having an argument about putting more solid wall into this. This is just simply what they wanted. And the LEED Gold designation, I mean, the building does unquestionably use much less energy than a building, an equivalent building without sustainable strategies, uses much less water, et cetera. It's doing its job, but in terms of like going the next step, it's certainly a long way from it. And I think this is we're going to see another few floor-to-ceiling glass buildings in Toronto, and then it's going to be mandated out, I think, legislated out as a solution. One of the biggest problems they have with this project is simply lawyers come in to rent the space, and they say, you know, we love the view, we just love the view, but I really want a wood coffered ceiling. So anyway, and so these are the things you have to deal with in these spaces. And I'm just going to flick past this, but the interesting thing about this building is that this is, we try and model all of our energy use on our buildings, and this is the baseline performance in the simulation at 308 kilowatts per hour, and it's actually performing at 245, so it's working kind of incredibly well. But what it's done is it's set the standard in the city now of what an office building should be. So now we have the Price Waterhouse Tower that's come on stream, TELUS, it's come on stream. Oxford's about to build a platinum rated building in downtown Toronto. So it now becomes that's like the marketing tool is it's got to be LEED certified, which means that all the rest of the downtown, including First Canadian Place and Toronto Dominion, need to up their game to meet that requirement. Toronto has no history of retrofitting buildings, really. So for us, when we started sort of down this avenue, we started sort of thinking about other areas where you can see these kind of retrofits going on. And of course, New York is the place where they even if they don't need to do it, they keep on reinterpreting buildings so that they can keep their market share. And it was kind of fun to look at this building. It's a building I studied when I was doing my thesis for tall buildings, one of the first tall buildings in the world. And it occupied a central place in New York. It was fully steel building with high-speed elevators at the time. It was wrapped in terracotta. It had a very particular relationship to the city that was very important. It was on all the postcards and so on. But over time, the city, of course, grows around it, so it becomes less and less important, and they can't keep their rents up and so on. And of course, it's one Times Square, and in this context, it starts to lose its importance. So it gets bought, it gets stripped, it gets a new cladding system, and over the years, bits and pieces of stuff keep getting added to it. So it gets fully reinterpreted and becomes, the building that we see as the kind of icon of New Year's Eve the world over. So, I mean, that to me is a kind of classic piece of, it's like the Theater Marcellus, where it becomes a kind of completely different building. Its use as an office space is almost irrelevant to what it's become in terms of advertising, and apparently they make much more money in the advertising they do from renting the office space now. Which brings us to the TD Centre. And so now we have these structures in downtown Toronto. The TD Centre was built in 1967, and it finished and opened in 1969, the first tower. And it's a classic Mies van der Rohe building. I think it's still actually incredibly powerful, but it really changed Toronto. My father, who was an insurance adjuster, just thought this was the most amazing thing that had ever happened to Toronto. And, like I say, we would go down there on weekends and look at the place, and he just thought this was the coming of age for the city. But of course, so it comprises 5 structures. These are also part of the system of 5 towers of varying degrees of quality. The original 2 are the Royal Trust and the TD. It's no longer the Royal Trust. And then another tower on the site beside the banking pavilion, which I would say is less distinguished, which was built on top of the stock exchange, is a modern form of the Mies van der Rohe tower. And then we have 2 other towers that have been built alongside it of varying degrees of quality. This one is the 3rd tower that was built, and we'll talk about that in a second. But the biggest kind of architectural expression of the building is the exposed structure on the outside, which isn't actually a structure, but the kind of expression of that structure, and the floor-to-ceiling glass running up the building with the bronze tint to it. Now, boy, the color is really off here, but you can see here that the structure's, of course, gotten quite run down. All the sealants are popping out of it. This color is supposed to be jet black, and so the building, although we still look at it and see it as being black, it's actually battleship gray, and so that it has a kind of amazingly crazy notion about how to build, and it brings for me the kind of thing about how confident we are in our time. And this was like the most extraordinary technology of its time, and everybody thought it was going to last forever, et cetera, et cetera. But it's single glazed. This is steel bar stock for the window stops. These are two steel channels stuck together, and then a steel I-beam section stuck on the outside of that. This is outside, this is inside. So it's basically like a perfect radiator. It just sucks the energy out, whether it's cold or whether it's cold coming in or heat going out. It's the perfect radiator. There's no insulation whatsoever in the system. There's a teensy-weensy bit in the spandrel panel, but otherwise it's basically like you're sitting outside. So we face this dilemma that at some point Cadillac decided to transform the building as pieces of this were slowly rotting out and rusting out, that it just came time to deal with it. And of course, in this case, the architect's job is to be non-existent and to do something where it's like you don't exist. It gets done, nobody sees it, including the tenants inside the building, that somehow it gets transformed, and at the end everybody goes, oh, it's a Mies building. So we studied of course it starts with like, how do you take the thing apart? And everything's welded and so on, so there's a lot of kind of work in just figuring out how you remove the bar stock and remove the glass from that piece. And then to develop an extruded aluminum section, which we'll just zoom in. Pardon the fuzziness of these, but you can see the kind of point that this is an extruded aluminum section with a very tough but and small thermal break in that system, a fully double sealed unit with a little bit of a low E coating on it. And then we put some foam insulation into the core here to improve the assembly. Now, it's still a terrible skin. Like, this is still a full radiator thermal break that's running right through the thermal bridge, running right through the system. But just the addition of this allowed us to take out the induction units at the base. And these are like 20 inches by 23 inches high. To remove those and then put them up into the ceiling with a much more efficient chilled beam system, induction unit up in the ceiling. And just that alone reduced the energy load in the building by about 30%, which is, for a building that size, is incredible. Like, it's just a massive amount of energy. So this is just showing the kind of beginning of the techniques that we use for taking the building apart. And sorry, this is the induction unit up in the ceiling. And it begins with a whole program of dealing with lawyers and so on and so forth, so that at 5 p.m. they pack up their stuff in boxes. The guys come in and move all the stuff away from the window, do it one bay at a time, bring down the swing stage, and this poor bastard has to be on the outside digging gaskets out of the building and grinding pieces off. The glass gets removed to the elevator from the inside and then brought in from the inside, replaced. The furniture goes back at 7 a.m. and happy people have returned, having noticed nothing changed except for better windows and no incremental units. And it sort of worked that way. Amazingly enough, there were only about 17 floors unoccupied in the building. So here you can see the opening in the window and the guys working up on the platform. And then we had to develop this thing where, and you can see here, this is the gray existing paint. And these are new programs for studying the repainting of things. So the building is painted with this carbon-based paint, which is just fantastic stuff. They use it on bridges. They used to use it on bridges. Technically, it doesn't really dry, but it's as toxic as it comes. Extremely toxic. So it's technically illegal to use now. So we did some research with the Mies Society in Chicago to start looking at new paint systems. And this is just showing 5 different specifications, which we developed, and then it just sat there while we're doing the rest of the building program, so we could see it through one cycle of transition. And you can see that this is showing those elements, the leftover elements, while we painted the rest. And you can see like different levels of sheen on them that developed that weren't satisfactory and so on, because the original paint was actually quite dead, so to kind of develop that. So this is the final rendition where you can see the new stuff and against the old stuff. And so the final result is floor-to-ceiling glass, and in terms of the effect to the client. So now it's actually fully competitive with the RBC tower, and it's a building that was built in 1969. Its energy load is not quite as good as RBC, but it's right up there, and it's now rated a LEED Gold E-bomb building. So it's actually, it's being transformed dramatically from its former space to what it is now. Now, of course, in the interior, we had to do all this work on the interior as well. And again, trying to salvage as much of the kind of Mies quality and look as possible. And in some cases, that went a little awry, but of course, these things are always problematic. I love these pictures of kind of fabulous outfits. But the transformation of the new, like putting in new lights into the ceiling that have low energy loads, LED lights, redoing the cabs, elevator cabs, so that they come up to barrier-free standards, so instituting stainless steel rails. And this is a kind of classic example where things go a little wrong, that the original detail at a kind of glowing trough up here, we replace it with LED lights, and they're developing too much of a hot spot in those areas. And then the lobby itself had to be completely torn apart. The mechanical systems up here had to be completely replaced, and the lighting. So first thing is to institute a kind of system where people can walk through it in safety while you have a working platform above. And we removed all of the mosaic tile from the ceiling, which was all kind of damaged in spots and so on. And then we took all that mosaic tile and we tore it all apart into individual pieces so that we could tumble it. This is all done on site. Tumble it to clean all the material off of it, and you can see it here before it's tumbled. And then create new panels by mixing in about 20% of new glass tiles. So it would still, we couldn't replace the Mies tile with the original. It didn't exist any longer. So mix in another 20% of tile. And then, so again, this is all done on site and replaced in the ceiling. We also removed all the kind of various junky programs that you put in there over the years and replaced grills and so on. So it's very crisp now and is energy efficient. So the program also included tearing apart the plaza. Isn't that great? Removing the cows, ripping everything up. This was completely uninsulated. So, so getting in there, replacing all this with modern waterproofing, and then new insulation, and then the new tile surface on top of that. So that also, because the whole underground layer of this building is entirely a shopping mall, so it improves again the energy performance of the mall. And then as a kind of finale, Cadillac Fairview asked us to look at turning this into a green roof. I mean, it's funny because in some ways, I'm not going to go back, but every developer needs a symbol of sustainability. And the common symbol is photovoltaics, which are, again, total nonsense in that they only work unless you have a lot of input, like tariffs put into them, and they just don't deliver the energy. And if you took all the millions of dollars you spent on photovoltaics and spent it on your envelope, you'd have real benefit and real direct benefit for your building. But of course, your envelope, it's not sexy, and photovoltaics look great to stand in front of, and they're purple, and they're terrific. And I'm not kidding. This is like standard thing in my practice that everybody wants photovoltaics in this building. And you'll see in a second, we had to do this across in First Canadian Place, do a whole study of like putting photovoltaics on the facade of a white icon in downtown Toronto. But green roofs are something that everybody can see, and so we did this study for putting a green roof on top of the banking pavilion that starts with kind of a multicolored thing, which many of us in the office found appalling, but nonetheless, you have to go through these things, and fortunately, there isn't enough sunlight here to promote colored flowers, so we ended up with a type of grass, not sedum, but a kind of type of even grass that's palletized, and that program is now finished, and it basically looks like this. This is still a rendering, but it basically looks like this. So it's the only thing that kind of breaks with the Mies tradition of something actually growing on your building, but anyhow, it seems to be working. So center, I think that it's kind of the perfect idea of like this is a thing where you don't want to mess with it. It's got to be perfect in its kind of reconstitution and regeneration and transformation, and kind of bringing it back into the relationship to the city that it's had, and making it competitive in the marketplace. I mean, weirdly enough, that even though this place is listed and everything else, Cadillac often talks about like tearing this down and building something in its place, and so on and so forth. So it's important that we kind of keep these structures interpreted and germane. Otherwise, they tend to disappear. So at the same time, we had the great good fortune of working across the street, and this is sort of an interesting photograph. It's an old image of downtown Toronto, but B+H, this is one of the first buildings that they did, quite large, and it has been working on these structures now for the past, well, since 1969, 67, I guess, and then across the street, we started work on this building in 1973, First Canadian Place. It opened around 76, 77, and it's been a lifelong relationship with the building while it's being bought and sold by miscellaneous developers. We've been working on it ever since. And it's 2 million square feet of kind of legacy for us, and we've had really kind of a love-hate affair with the building ever since it was built, and we'll explain why in a second. So the structure was quite extraordinary for its time. It was a tube structure, where as opposed to the TD Center, where the main structure was the core. You have concrete in the interior, much lighter system on the outside. Most of the lateral load is taken by the core, whereas in this case, all the structures move to the perimeter, and it's built in 3-story lifts of these kind of T's, which will be familiar to most of you from the destruction of the World Trade Center in New York, which had a very similar system that was essentially pioneered on First Canadian Place. So the system, you can see here that everything that is white on the building is in fact steel, and it was clad from top to bottom in Carrara marble imported from Italy. The panels of the marble are 1 3/4 thick, and I just want to point out this bit of legacy. This is Tony Alcazar here, a senior partner in our office, who's now 75 and still works in the office, putting up the last thing. Look at all these boys with their pipes and so on. Anyhow, this is just, I won't go on too long about this, but of course I'm standing here saying we, but it actually is we, Liz, and these things require huge teams that do the analysis on these buildings and so on. So this team was called in to work on the building because one of the panels a number of years ago fell off the building and dropped 40 stories to the podium, thankfully, below. It exploded, sending marble all over the place and gravel from the roof. All the streets surrounding it were closed while people figured out what had happened. And what had happened was, you can see that the entire thing has gotten kind of old and musty, but at the same time, we have this process taking effect called hydrothermal hysteresis, wherein the marble, which is in fact porous and absorbs water, and then its front face dries out, but its back face doesn't, so it starts cupping like this. And it's just like a wood floor in a basement or something rather, but it develops a memory and it doesn't go back. And over the years, it gets slightly worse and slightly worse until you can see, in some cases, we had bending out a plane of almost an inch, which in an 1 3/4 material is extraordinary, which puts an incredible amount of stress on the pintles and connection systems. But interestingly enough, everybody was building out of this stuff at the time. This was a project done in a joint venture between Bregman and Hammond and Edward Durrell Stone out of New York. And he did 3 towers at the time, all built the same way, all with marble. And at the time, our sensible Tony Altazar said that he thought it was a lousy material to put on the building because it was so porous and not good for our climate. But Edward Durrell Stone said, look, Alvar Aalto's doing it, and this is Aalto's building where you can see the same effect. I think it's fine, and the Reichmans at the time were the major importers of the product from Italy anyhow, so we were overruled, but we wrote it down. So it's very important, because when the piece fell off, of course, the lawyers immediately come to you and say, hey, your building's falling apart, and then you produce a letter and they say, oh, hey, well, okay, let's get on the team, let's figure out how to replace it all. So sometimes it's a good thing to figure out, to write down your issues with decisions that have been made. So I just want to show, this is a diagram from the late 70s that shows the wind loads on the building. And of course, number one, it was kind of poorly understood, the effect of wind loads on buildings. But you can see the kind of hot spot here. This is where the major wind loading occurs, is at the top of the building. But then as we move forward and the city gets built around this tower, and this is a new wind study that we had to do to sort of see what was going on the building, it changes the velocities dramatically around the building. And in fact, it starts creating kind of Venturi effects between the towers, and the highest speed wind velocities start up here and they drop down to here, and you get this phenomenon called vortex shedding, where the wind kind of peels away from the corners, and it started happening here, and this is in fact exactly where the panel fell off of the building, and so the model actually predicted that this would happen. And so when we went to redo all the cladding, we of course reinforced all these areas in yellow to have to deal with higher loads because of the increased density around the building. This is the renewable energy solar analysis, which of course we had to do because somebody said, oh, we've got to put solar panels all over the building because they look so great. And so this was a kind of study to look at from the 70th floor to about the 50th floor, to see how much energy density we get on the south facade. And by the time we did the kind of analysis about how much money it would cost compared to how much it would pay back, it would take about 100 years to pay for the solar panels in a kind of legitimate economic model. So we took the money and put it elsewhere. So then, as part of the study, we have to look at sort of methodologies of construction, because in this case, everything had to be done on the outside of the building, as opposed to the TD from the inside. So this is the Aon building in Chicago, which is also an Edward Durrell Stone building that started failing about 7 years after it opened, and they had to reclad it all from the outside. And in this case, the pieces of marble were raining on the streets below, and they had to close effectively most of the streets before they started this process. So taking all that information and sort of understanding what we had to do technically in terms of reinforcing the facade and so on, we then sort of look at what the new suit is, which is the design exercise for the project. And so again, this is just showing up close the marble situation. So the existing building has panels at every 10 feet. Can I talk in feet, or I need to talk in meters as well?
Anyway you want.
Anyway, it's all good? Okay. Okay. 10 feet by about 8 feet and divided in 4. So each panel is 2'5" by 4 feet by 1.75" marble, so you can imagine a very heavy object. You can see all of the sealants are leaching into that marble, in particular where the pintles are at the base, where you've got water wicking out at the bottom of the system and is bringing silicone, old silicone, out to the surface and is wicking back into the marble. And here you can see the problems of the thing bent out of plane. That the first thing that happened after the piece fell off is they put these, you can see these rubber bands that ran all the way up the building, embedded in silicone to try and like keep everything intact, so things wouldn't fall off. So I mean, the building was looking really ugly. It looks kind of like a university student's basement apartment shower or something. Anyway, so so as part of the study, we just looked at piles of different ideas about how to deal with the facade, from full recladding, reoccupying the corners, putting office space or something rather into the corners, to recladding with various materials. Maybe, okay, let's say it just stays white. Can we do something with different material options, stone, precast, metal, microcrystalline panels, or in fact doing frit patterns into the glass that kind of change the kind of apparent angularity of the building and kind of hype up the form. Could it be blue? Could it be zebra? Etc. And of course, like these are the sort of things you have to go through all these exercises, in particular with clients who are just so nervous about the amount of money they're spending, and the kind of thing of, well, how are they going to know it's new? Like if you just make it white, and this is a question that comes up over and over again. So ultimately, what we decided to do was that it was really important that the buildings stay white. That's the icon. That's the place that it occupies in the city. The white tower, the black tower, I mean, it's just the city, it can't be any other color than white. So how do you transform it, but give it a kind of new aspect, new character, and amp up its kind of sustainable components? So this is the final constitution of the building, with a slight adjustment to the crown on the top, keeping the building white, but now replacing the marble with glass all the way up. But then taking the corners, and it's funny because I never liked the corners. Even when I was a kid, before I was an architect, I always thought they were kind of ugly and dumpy. And so we got the opportunity to actually take these and almost make it more like 4 panels attached to the tower, instead of sort of a homogeneous cruciform envelope. So we made the corners of bronze glass in that case. So here's the assembly as it existed, with its 8 panels of marble, existing strips of windows, which we kept. The glazing was actually in very good shape, and over the years, about 25 to 30% of it has been replaced anyhow, as it kind of aged, or they broke, or the seals broke in the system. So we just left the glass. We did testing on it and realized that even taking it out, by the time you took it out, the cost benefit just wouldn't be there. And from a sustainability perspective, much better just to leave that glass in until it fails, and just to work on its flashing components and so on. So we went with this idea of replacing all the stone with a panel of glass that's about 8 feet by 10 feet, which would be, like, just to put it in context, it's a huge piece of glass. It's almost the size of this image. And then to replace all of the curtain track as well, and all of the seals and gaskets and the flashing. So this is the kind of final decision about how it should look. We have the glass panels, the darkened bronze corner, and then the issue becomes how to actually make that happen. So you can see here, it's just very subtle, but we made this decision to create sort of some texture on the surface of the building by taking the technology of glass, and we ended up with, from a structural point of view, laminating 3 layers of 1/4-inch glass into the system. And then so we decided to put a frit pattern into what's referred to as layer 2, or surface 2, and then an opacifier at surface 5. So you have a kind of 1/4 inch of depth there to create some shadow in that plane. And once we kind of decided that, then it sort of got into this thing. And this is one of the mock-ups, and you can see that sort of effect the shadow line that starts to get created within that depth of 3/4 of an inch on the building. It's very subtle. But then it sort of became issues of kind of how to construct that. So you can see here, that's the idea of like how you take apart the pin. Just put 2 gravity anchors on the top and lateral on the bottom, and you'll see how that works in a second. And then this kind of layer of three layers of glass and onto a metal frame. So that's the kind of system there, and we'll talk about that a little bit more in a second. But then we kind of got into this thing of what's that frit pattern look like. And since we now have like 6 layers to play with, we started fooling around with this idea of what can you do in those kind of 3 layers and that kind of depth. So one of the things we thought was what would happen if you had 2 layers of frit and you kind of put them against each other and started rotating them, which gets you into these kind of moire patterns, which you can twist and turn and stop at whatever point you want. But at some point that became kind of arbitrary, so we thought we'd go back and look at the work of Edward Durrell Stone, in particular the way he did these screens and so on, and then settled on this idea of how he did the kind of screens in later life where they were more triangular patterns that he used in several of his work. So then we started working with the kind of triangular patterns, and this was actually when the job was fun. We gave out these kits to all of our clients where they had 2 layers of these frit patterns that they sat there and kind of rotated. It's great to see guys in suits do these things. But at some point, you know, it all becomes just a little too fussy, so we just settled on the idea that it should just be a simple triangular pattern, but with a kind of depth to it. And so this is the final sort of idea for that piece. And now you can see the glass, the gaskets, the trim pieces that cover up the hex bolts that hang the component in place. Now, I love this because this just shows the kind of testing that had to be done for the glass. This is showing that sheet of glass, but you'll see this guy's just using a center punch, and there's so much stress in the heat-soaked glass that it almost knocks the guy over. And the point of this test is to demonstrate that the glass will fracture down to a size that if it fractures out of its frame and drops the street, it won't kill anybody. It just comes down as a kind of shower of glass, as opposed to sheets of glass. It's a big difference. Big difference. I mean, all that said, this thing is going on with balconies in downtown Toronto. The weird thing is they performed exactly the way they were supposed to, but now everybody's scared of balconies with glass. But now they're saying they're going to laminate the glass. So now you've got sheets of this stuff. It's all broken up like this, but it's all attached to a chunk of plastic. So it's a question about what's better. You know, chunk of plastic and glass falling on you or a little piece of glass. So anyhow, that's a whole other debate. So this is the process. We start with the system, remove the stone, remove all the insulation that's in there, burn off all the clips that are there to support that stone, and remove also the window washing track, and then reinstitute new clips for the window washing track, new insulation, and there's one thing that's missing from here, which is to actually go back and caulk all of these pieces, replace anything that's damaged, replace all of the flashings, etc., replace the insulation. The new panels come in, and new trim goes on, and it's finished. So that all looks very simple, but of course it's like that's just the design. And what was interesting for us and quite rare for an architect to be involved in is that the whole process had to happen on the outside of the building. So we were actually involved directly with the logistics of construction, which generally architects not only we usually run away from for liability issues. But in this case, the climber had to actually be fully integrated with the design, in that as it moved down the building, it had to be clipped into the building and then unclipped and then clipped into the building and unclipped. So we had the opportunity to actually work directly with a group out of New York who built the system, and to integrate it into the assembly for the building. So it starts with, first of all, it's 3 layers of structure, and on the top layer is where the glass is put in. The middle layer is the kind of structure for attaching it to the building. The lower layer is for remediation, removal of the stone. And then you can see each truss is related to the column and the 10-foot module of the structure. And it has kind of skates on the top and bottom, which I'll show in a moment, that are integrated into that window washing track. And then that's where the kind of system is hoisted up and down. But in fact, what happens is that we have 57 winches on the roof. So that's the track, the skate goes in here and goes in here. That's the structural component there, structural level, glass platform and stone platform. So the platform is lowered a floor with the winches. The cable runs actually down in the window washing track and connects in there. And then it's lowered down, and there's nobody on the platform when it's lowered. And then it's bolted into the steel assembly. And then at that point, people can come back onto the platform and move things around. So no weight is like borne on the winches. It's just actually on the structure of the building. So it's an incredibly safe platform and allows for a huge amount of kind of movement of large material. So this is actually, to me, interesting. This is an architect's drawing. It looks a bit like a shop drawing, but this is our interpretation of the structural system, how it's going to bolt into the assembly, how the skate attaches in, and how it's going to work kind of on its way down. And it's interpreted into a shop drawing. So here you can see all the winch points around the roof on the top floor. These are the four elevators on the east and west facades, again, bolted fully into the steel structure. And you can see that how the truss works here. It has two attachment points here and here into the steel plate, the 1/2 inch to 3/4 inch steel plate that's the spandrel. So this is a artist rendition. Oh, it's so easy. So this is assembly, it's coming down. So it moves into place, remediation on the lower level, and then the new glass is installed. This is just kind of a view of, so remove the stone, remove the insulation, cut off all the existing hangers, new insulation, new blue skin, new hangers. And then this is the glass assembly, which starts with a clear glass, an opacifier, another sheet of clear glass, the frit pattern, which is burnt into surface 2, and the outside plane of glass. Lovely sandwich. Away we go. So this is the thing in practice, and so we start. This is the upper level of the system. So this is showing just the monorail, which runs on both levels. We'll talk about the rest of the cone in a second, but you can see the new extruded window washing track on the left. So we start with the elevator. And the elevators are all tied to wind speed indicators, so they stop automatically. And we have a monorail track for pulling the glass on and off the platform. Here you can see the outside truss system from the elevator. And then this is one of those great accidents that happen in construction. So this is on about the 42nd floor. It's this random piece of stone that has this hacked into it. My daughter and I tried to translate this. She actually takes Latin, but so it says, "The stone from Italy obtained from the patrician father A.B. Ottoni is drenched with sweat and tears." It's like, there's construction for you. Anyway, we found the guy who was about 75 who had worked on the site. He ran the crew, and we found him and asked him about it. And he said, "Oh yeah, we put that up there," so we gave the piece of stone to him. Anyhow, it's kind of a fun thing. So here's the process. Removing the stone, putting it on carts, and off it goes. So this, again, is a process that I was always intrigued by, that as we moved along, you can see that's the pintle there, and there. That's all it's held on with. And here you can see the assemblies there, and you can't quite see it, but there's a kerf that's knocked out here and here. But that kerf is attached to these sort of T-plates here. And at first we had a kind of system where you cut away at it, and then you got a grinder and you ground it off. But these guys, they were all so into it that slowly the process got faster and faster, and they started designing their own tools. So a guy showed up one day on the site with this kind of cat's paw system, and you could see clearly where, because of the staining on the marble, where all the pintles were, and you just take this thing and go like that, smack, and they could remove a panel, each one of these panels in something like 3 minutes at the end of it by the time they got to the bottom. So here's the remediation of all those the components underneath the windows, and then new insulation being put on, but you can see the kind of blue skinning patching in various places. Welding on the studs for the bolt plates, and then here these are the plates that the structure gets attached to at that point. So this is the structural level. So these get attached all the way up and down the building, and you can see like this is we're up at about the 60th floor in this image, and it feels like you're standing on at home. A little windy, but and then these are the hang plates that get attached to hang the actual assembly all the way along. The glass gets installed at that point, and then the new trim kits get put on. This machine here, the suction cup machine, it's funny. Like this was a kind of thing where you see these huge pieces of glass being swung along this thing. It just gave me the willies. And it also turned out to be actually really unwieldy. And at some point, about halfway through the process, another guy said, I got a better idea, and you'll see that in a second. So here it is going into place. So there's the gantry.
Yeah, no, but exactly. See how tight it is?
And you can see how close that was to the perimeter, so that all the tolerances are very, very narrow. So my dad filming my phone.
Go ahead.
I don't want to spoil the picture. I don't want to spoil the picture.